the quest to go higher and faster than ever before. Witness the technological breakthroughs that produced the first supersonic bomber. Fly 3 times the speed of sound on great planes, the XB-70.
This is a United States Air Force B-1B heavy bomber when it was first shown to the public. Apart from modifications to the engine intake, very few would have noticed any difference between it and its predecessor, the B-1A. However, because of the evolution of technology, the B-1B in many ways was a very different aircraft indeed from its predecessor. The A model was to fill the long overdue requirements for a new American heavy bomber. However, due to political, more than technical problems, the project was cancelled. But over the next several years, Rockwell, its manufacturer, and the Air Force revised the aircraft's parameters. Now, taking full advantage of the aircraft's swing wing potential, Rockwell developed an aircraft that could fly long ranges at extremely low levels to avoid observation by enemy radar. Many of the differences between the A and B models can be found in various forms of detection evasion electronics. So this potent weapon is able to fly quite literally unobserved into the heart of enemy territory. There is one other major distinction between the A and B model, and this is simply that the latter model, although the product of much considerable technical innovation and several years of additional development, is in actual fact slower than its predecessor, simply because an aircraft that could not be seen does not need to have the extra advantage of speed. However, this was not always the case, and virtually throughout the history of aviation, the quest was for faster and still faster aircraft. Probably the biggest single step forward in the search for new technology to gain higher speed came with the advent of the jet engine. But although it was to be pre-war Germany which first utilized jet power, American engineers employed the concept on experimental aircraft way before the war's end with aircraft like this Bell Aero Comet. The first major development of the post-war years was the record-breaking Bell X-1 rocket-powered experimental aircraft. Dropped from a Second World War bomber on December 9, 1946. In the hands of test pilot Chuck Yeager, it was to break the sound barrier for the first time. The continuing development of the rocket plane produced the X-2, still faster and higher than any of its predecessors. This experimental aircraft also was to rely upon aerial launching from a heavy bomber. The quest for higher speed put phenomenal stress not only on aircraft, but also on their pilots. The risk of even a minor malfunction at the speeds now being attempted was enormous, and the sensations that every pilot carried with them, as they would constantly be required to keep increasing speed, are something that they alone could experience. Much of the data gathered by X-plane tests was to be used for military objectives, because with the technology of the day, the faster aircraft were the less vulnerable and therefore more effective. By the middle 50s, the American Strategic Air Command was deploying its first all-jet long-range heavy bomber in the form of Boeing's B-52 Stratofortress, a giant plane with 8 jet engines suspended below fully swept wings, which enabled this aircraft to fly at speeds in the order of 600 miles per hour and with great payload. But although the B-52 was to prove one of the major successes of post-war aviation, its speed was nothing like the X-planes. The next major step in the quest to increase the speed of bomber aircraft came with the B-58 Hustler. This was a delta wing concept developed by Convair to produce a bomber aircraft which could actually fly at and sustain supersonic speeds, but to obtain this performance, the plane was relatively small and could only be classed as a medium bomber. During the early 50s, when the Cold War was at its height, SAC perceived the need for a bomber at least as large as the 52 and with a speed still faster than the Hustler. To achieve this hitherto unthought of speed with such a large aircraft as a heavy bomber would require a phenomenal power source, and temporarily discarding normal jet power as being inadequate, American aviation engineers looked towards 2 alternatives. The first was nuclear power, used successfully to propel submarines. At that time, nuclear power was considered as a possibility to propel a long-range bomber. To this end, Convair converted a conventional B-36, not unlike this one, to actually carry aloft a fully commissioned nuclear reactor. The crew was successfully insulated by lead shielding, and although no attempt was made at this stage to transfer power to propel the aircraft, tests were carried out in earnest. And various designs were put forward for bombers which would at least in part be nuclear powered. However, the biggest problem here was the nuclear ramifications of an aircraft crash over populated areas. Another alternative for the requirement by SAC were various proposals to carry large amounts of so-called zip fuel, such as boron, which would be consumed in copious quantities. Prior to the plane making its final dash, its enormous fuel tanks would be dropped, allowing a lighter aircraft to make the attack. But a far more novel approach to attacking the problem came from North American aviation, which used a concept of compression lift. The plan provided for 6 enormous jet engines contained in a tapered shape under the aircraft, thus forcing air away from the center section at high speed. The design also allowed for this air to be trapped by the outer edge of each wing when it was lowered. The compressed air would act to lift the aircraft and help propel it at a speed 3 times that of sound. The XB-70 design was accepted by SAC in December '57.
Wings will return in a moment. And now we return to Wings.
North American had a long string of successes, including a recent solution, the Navy's need for a supersonic strike bomber. By providing the twin-engine Vigilante, this aircraft was to combine in a small area speed and bombing capacity never previously made available for carrier use. But now, having put forward the compression lift concept for a bomber, North American's big problem was heat. wind tunnel tests proved the theory could work, but produced such heat as to warp all previous conventional materials. To tackle the problem, North American would employ a honeycomb sandwich material made from stainless steel. It offered strength and dissipated heat through its honeycomb structure. The availability of this technology was fundamental in dealing with the problem of heat caused by speed. After 12 months of testing designs and mock-ups, an order was placed for one XB-70. But the aircraft, now called Valkyrie, was in for a stormy time. 2 years after accepting the concept, financial pressures obliged the government to limit production to the one prototype. And although the following year extra funding was made available for the program, the Air Force was having trouble holding on to its supersonic heavy bomber. The final blow came with the newly appointed Pragmatic Defense Secretary, Robert McNamara, who redefined the XB-70 as a high-speed research project and limited production to just 2 aircraft. But at least the concept was still alive, and its proponents hoped it still might ultimately be accepted for military use. In 1963, at least one aircraft was well underway. The problems with dealing with new strong metals are sometimes solved by chemical milling, using acids to shape what machines could not. Sealing the massive fuel tanks would always prove something of a problem, and especially on the second prototype, elaborate precautions were taken involving engineers being sealed up in fuel tanks, which were then pressurized so that a solution could be applied to welds to test for flaws which might otherwise escape detection. Slowly, as the months passed, the components came together. At this stage, the wings were ready for welding to the main fuselage. And after this was completed, every inch of the join was X-rayed for strength. With equipment like so much of the Valkyrie project, it was especially developed for the one task. Now the massive craft, arguably the largest aircraft ever designed, was taking shape. The engineers worked rotating shifts to ensure the aircraft's completion. But at no time could any shortcut be taken with a plane that was designed to fly as fast as a bullet. Everything was tested and tested again. When the supporting structures were finally removed, the first XB-70, serial number 20001, must have presented an awe-inspiring sight for those lucky enough to see it. But it was not until May 11th, 1964 that the press and public were given their chance to marvel over North America's sleek white wonder. Brigadier General Fred J. Escani, who directed the B-70 System Program Office, described the plane's various features.
Most of the structure in the wings and fuselage is of stainless steel. These are our now famous honeycomb core sandwich panels, and many of the outer skins on these honeycomb panels are as thin as 7/1000ths of an inch. The two-man crew will sit side by side. The crew station in this position is about 20 feet above the ground. All of the space aft of the crew compartment is taken up by fuel, both in the fuselage and in the wings.
Before the XB-70 is poised at the downwind end of Palmdale's 12,000-foot runway for its first flight, numerous ground tests would have to be performed. Shortly after its debut to the public, the aircraft was again supported by jacks, whilst the electrical and hydraulic support systems were thoroughly tested. To achieve this, at a time when the engines had not been run, a ground auxiliary unit was employed to provide necessary power source. With this auxiliary power, all moving surfaces were subjected to vigorous testing. All flight controls, including the forward canards, the ailerons and rudders, were fail tested and tested again. Like so much of the XB-70, the undercarriage, which was to support its phenomenal weight, together with the added stress of landing and takeoff, was for the time a unique and brilliantly designed structure. The forward twin wheels were conventional enough, but the main support gear would be required to rotate as well as fold the four-wheel bogie mechanism, which would be stored in the limited space available. And the whole process of extension or retraction of this clever but complex gear could be achieved in a little over 20 seconds. All of the many and complex tests that were to take place during the weeks before the first takeoff were recorded in a special flight test instrumentation package, a self-contained airborne unit, the first of its kind which was actually contained in the aircraft's bomb bay, and remained with the aircraft for ground, taxiing and in-flight tests. One of the final tests the XB-70 prototype was subjected to were vibration tests, designed to expose the gigantic fuselage and wing surfaces to the effects of vibration far beyond the point which it might expect to encounter in flight.
Wings will return after these messages. And now we return to Wings.
As aircraft tests proceeded, air crew were introduced to some of the engine's characteristics. Here at the Arnold Engineering Development Center in Tennessee, a YJ-93 engine was set up, identical to that which was to be used in the Valkyrie. It would be installed in a test chamber to give flight crew their first experience of its enormous power in artificial conditions, similar to that which the crew could expect in flight. Seen here is Al White, North American's chief test pilot, the man chosen to take command of the XB-70 maiden flight. With him is Air Force pilot Joe Cotton, who'd be the co-pilot for much of the early test program. Another team shown here are Van Shepard from the aircraft manufacturer and Lieutenant Colonel Fitzhugh Fulton from the Air Force. They would represent the backup crew should one be needed. For months, these men would be embroiled in an extremely busy schedule of learning the techniques required to fly the world's most advanced and ambitious aviation project. By early September, most of the exhausting static testing had been completed. And now the most revealing tests would begin. Tests with aircraft in motion and, ultimately, tests with the aircraft in flight. Before the engines were fired up, the complicated in-flight recording systems would be primed to record every technical event as it occurred. This view of the Valkyrie gives a clear picture of what became known as the six-pack, tightly gripped together, a phenomenally powerful combination of 6 mighty jet engines, which were hopefully to propel the Valkyrie at speeds not many years before considered impossible. And now, with its own power source available, all of the hundreds of mechanical functions which have to perform perfectly if the Valkyrie was to succeed were checked, as the aircraft was removed from all external power sources. After a series of taxi runs, pilots and technicians were happy that the Valkyrie was ready for its maiden flight. On September 21st, 1964, the first prototype of the XB-70A was positioning itself at the end of Palmdale Runway on what was to be a very historic moment for North American aviation and the United States Air Force. Here, as planned, White and Cotton were in the cockpit. At exactly 8:38, the Valkyrie took to the air for the first time in what was to be a series of epoch-making test flights. This enormous size and unusual shape must have made a breathtaking sight as it took to the air. Accompanied by a single chase plane, simple routine checks were made as the pilots experienced the ways of the Valkyrie in flight. One of the first functions was to retract the aircraft's advanced undercarriage, but here a problem occurred when the mechanism failed to respond.
Crew has rotated and stopped, is not holding.
Okay, they are static, is that right? They're not moving?
That's correct.
White, with millions of dollars of high technology in his hands, set the landing gear back into its original position. And all concerned must have watched with unbelievable tension as the gear slowly responded to the cockpit control. Clearly, the first tests were to be made wheels down. Nevertheless, an alternative plan was available and the plane continued on its maiden flight, although one engine was shut down when a warning light flashed. Still, over 60 minutes of valuable test flight was gained as the aircraft headed towards Edwards Air Force Base.
50 feet. 30. 20. 10. 5. And you're on. A beauty.
But one of the rear brakes locked, causing the undercarriage to catch fire. However, 20 feet above the ground, with the aircraft handling impeccably, the crew had to be told of the event by the chase plane pilot.
Jettison. Jettison.
Jettison. Jettison now, 74.
Your aft tires are blowing and they're both burning, but not very badly. You've got 3 fire trucks with you.
Two weeks later, the prototype, with the landing gear, engine and brake problems all resolved, was ready for its second flight. On an early autumn morning, with the sun reflecting on its lower side, White rotated Test Air Vehicle number 1 into flight. On this occasion, there were 2 chase planes, so that the undercarriage retraction could be viewed from both sides, as a second attempt was made to lift the gear in flight.
Here we go with the gear on the count. 3, 2, 1, gear up.
Handle up.
Again, anxious moments passed as the chase plane's crews watched.
Green lights are out. Looks good. Nose gear is up and door locked. We can wheel well. And both main gear doors are coming closed, and they're closed, and it looks clean now.
With the landing gear stowed, the Valkyrie could now continue to test at higher speeds. As the plane climbed in altitude, a warning light flashed in the cockpit, telling the pilots of a minor failure in one of the hydraulic systems. As an automatic precaution, White lowered the undercarriage again and headed the aircraft towards an alternative destination, Rogers Dry Lake, which would provide security of an 11-mile natural runway. The approach was smooth, the brakes operated effectively, and the Valkyrie made a perfect landing. After the flight, it was learned that a fractured pipe had caused the warning lights to go on, but considering the enormous complexity of the aircraft, this and the other problems encountered were hardly unexpected. The pilots reported that Valkyrie behaved in a predictable and comfortable manner. Clearly, they were coming to terms with the world's most powerful aircraft. Whilst the first test flights were taking place, construction of the second prototype was proceeding steadily. The massive tubular fuselage was married to the six-pack, and the enormous white fins which would give direction to the Valkyrie were already in place. For many of the lessons learned from the construction of the first prototype were rapidly reducing the manufacturing time of Air Vehicle 2. The second aircraft was to differ from the first in a subtle design change, adding an extra 5-degree dihedral to the wings, which was to improve flight stability. Here, one of the massive wingtips is being fitted. This unique feature is still, to this day, the largest single moving surface unit to be fitted to an aircraft. And their presence would enable the unique compression lift principle to assist in propelling North American's brainchild into the trisonic stage. Back at Edwards, Air Vehicle number 1 was rising to the sky again. Now, White, Cotton and the engineers had gained sufficient confidence to push the Valkyrie up to speeds beyond that of sound. On no less than 3 occasions, the plane was pushed into the supersonic realm and then lowered to subsonic flight. But doing so stressed the aircraft, which was designed to be flexible, and as a result, much of the thick white paint, which covered the aircraft surfaces, flaked and peeled away, giving the aircraft a model effect. But all concerned would have agreed that it was a small price to pay to get the 70 past the speed of sound. However, for this aircraft to reach its projected potential, it would have to go 3 times as fast. So tests continued.
Wings will return in a moment. And now we return to Wings.
October 24th saw the 4th takeoff, and at approximately 40,000 feet, the folding tips, which had previously never been used, were lowered to the halfway position. This would improve the aircraft's stability and reduce the wing drag effect. And at this stage, Cotton applied full afterburners to the 6-pack, and the slender white shape of the Valkyrie started its steady increase in speed. And on the 14th of October 1965, during its 25th flight, at an altitude of 70,000 feet, with the wingtips fully lowered, Air Vehicle number 1 reached its goal, 3 times the speed of sound. But despite its technical success and complying with all of SAC's requirements to provide a heavy bomber many times faster than the B-58 Hustler, the Valkyrie was not destined to be adopted in military service. The Air Force, knowing the plane would not be accepted as a bomber, had tried to acquire 150 70s for a reconnaissance role. But the survivability of high technical aircraft over enemy space was in considerable doubt. Soviet anti-aircraft missilery had effectively brought down the top-secret U-2, which could fly at heights previously considered safe from any attack. Missilery also competed with the high-speed bomber concept within the United States Air Force. Buried deep in underground control rooms, SAC's officers were to be given the option of the intercontinental ballistic missile as far more economical in development, deployment and crew. And the ICBM was, from the early 60s onwards, always to be considered the major attack vehicle with which to deliver nuclear weapons. The ICBM also allowed the Navy to assert itself, as its submarines offered platforms which were highly mobile and could not be detected, an enormous advantage which the Air Force bombers would not enjoy until the advent of the B-1B. But despite its lack of direct military application, the Air Force testing of the Valkyrie continued, as the two air vehicles would constantly demonstrate their unique features. One feature, the crew escape capsule, was a masterpiece of engineering. Should the Valkyrie depressurize, the capsule's clam-like top and bottom shells would automatically roll forward and completely engulf the crew member in an airtight module. From here, the pilot would still have limited control over the aircraft, and if it was necessary, the entire capsule could be fired from the aircraft into the air. These capsules were to play a very important part in the final chapter of Air Vehicle Number 2. Seen here with its slightly raised wings, Air Vehicle 2 takes off on a routine test mission on June 8, 1966. Al White was in command, but he had a new co-pilot, Major Carl S. Cross, beside him. Cross was an extremely experienced pilot who just joined the 70 project. At 8:27 in the morning, after testing, the Valkyrie was to form a formation with 4 chase planes, and the event would be recorded by an accompanying Learjet. The exercise was simple enough and should not have presented any problems. On the Valkyrie's inside right, there was an F-104 flown by test pilot Joe Walker, who was about to join the Valkyrie test program. Walker probably had more supersonic experience than any man alive. He'd just recently completed a flight program of North American's still faster X-15. This aircraft was the fastest X-plane and was virtually a rocket ship, which Walker could have flown into space. Flying below and slightly behind the Valkyrie's right wing, Walker's F-104 starfighter somehow went too close to the Valkyrie. This shot, taken from the aircraft on the Valkyrie's left, is here reversed to give some indication of what Joe Walker may have seen moments before his starfighter was somehow to connect with the 70's wingtip. Possibly it was the vector effect of the giant bomber that pulled the little fighter into its massive wingtip. In any event, in a matter of seconds, the 104 was hit and rolled into the inverted position across the top half of the Valkyrie's massive frame. As it did so, it struck both the 70's vertical fins and the left wingtip before it was to fall the thousands of feet to its destruction. Then, with a dreadful shudder, the Valkyrie rolled over and started a steep spin. Al White reached for the ejection mechanism within his capsule and was fired out of the stricken aircraft seconds before it was to strike the desert. His co-pilot was not so lucky and remained in the plane. Probably the G-forces of the descent stopped his ejection. By 9:36, Air Vehicle Number 2 was reduced to a smoldering carcass in the desert. Over the days that followed, technicians and project officials would examine the wreckage, but the story was simple enough. Somehow, the little 104 fighter had accidentally collided with the largest plane in the world. And on that fateful morning, in one action, America lost 2 brave test pilots and one of the only 2 Valkyries ever to be produced. Al White, who was the first pilot and had manned more flights of the 70 than any other, was ultimately to recover, but he did not fly in the XB-70 program again. The sole remaining Valkyrie, the first one made, was to continue the test program alone over a period of 5 years. It was to log 83 test flights, and the research that it and it alone could do would provide valuable information in the United States supersonic transport evaluation and many other projects relating to size, weight, heat, and speed. But in some ways, the Valkyrie had also been a military success. Years later, it was established that the Russians, fearing the potential of the XB-70, had been obliged to commit funds to develop their own smaller version. But the Soviet fear of the Valkyrie's success was also demonstrated in another way. For it's now known that it developed a high-performance MiG-25 Foxbat at tremendous expense. And this fighter's sole function was to protect Russia from bomber aircraft that flew very high and very fast, aircraft like the Valkyrie. The paradox was that it seems likely that Russian scientists used North America's Vigilante bomber as a pattern for their high-performance Foxbat fighter. The similarities are just so close, both in size and shape, that it seems certain that Soviet technicians were using American research of the early 50s to protect the Soviet Union from American bombers of the 60s. Eventually, even the one remaining Valkyrie was to be phased out of test service, and with an F-104 flying a farewell salute. Air Vehicle Number 1 was to land for the last time at Wright-Patterson Air Force Base en route to the United States Air Force Museum. Piloted by Fitzhugh Fulton and Ted Sternthal, it was still collecting valuable data even on its last flight. Shortly before it was signed over to the museum's curator, complete with its logbook at a brief ceremony. One of the pilots is reported to have said, "I would give anything to keep the Valkyrie in the air, except pay for it myself." But although the Valkyrie program had been expensive, and the cost of the project, divided by the number of flights, cost American taxpayers $11 million every time it took to the air, there could be little doubt that North American aviation engineers had not only achieved a technical wonder, but had produced one of the world's truly great aircraft.